What's up, my YouTube friends? It's time to build another portable antenna. So End-Fed Halfwave style antennas are fantastic for portable use. They don't require a feed line, they're resonant so you don't need a tuner. They're monoband typically, however you can add links for multiple bands or better yet add traps. Traps make band changes a piece of cake. My go-to antenna for my mountain topper MTR-3B is a tri-band End-Fed Halfwave with tiny little traps in it. Show you a picture here, and that thing works great. It weighs about 1.25 ounces for the whole antenna on a winder and packs up small, and I've worked the world with it. So let's build one. So let's go through our parts list here. We're going to build this kind of like the last 9-to-1, so we're going to need one of these solder window BNC connectors available on Amazon and eBay. We're going to need a toroid. This time we're going with the FT50-43 mix. So a slightly different mix, tends to work better for the End-Fed Halfwave. We'll need some of these tiny little guys. These are 100 picofarad, 500 volt. You could also go with 1000 volt. I would say 500 volt minimum for this project. Surface mount style capacitors, and these are just a ceramic 100 picofarad capacitor. And then we need some 28 gauge magnet wire. This is just the cheap stuff from Amazon, works just fine. So let's start this out by winding the toroid. We'll need probably 24 or so inches of wire. So we'll start with that. I'm going to double over the end here. Have that stub kind of point in toward the center, and I'm going to make 3 total turns with this doubled. I'm going to try to make it not cross over itself. I don't know that it really matters. There's 2 turns. I need 1 more here. So each pass through the center of the toroid is considered a turn. Alright, so I've got my 3 starter turns there. This end is going to go to ground, the short end. This stub right here is going to go to the center conductor. And then this wire is going to get another, I'll probably put about another, probably about 27 more turns. So a total of 30 turns on this toroid. I like to start with about a 10-to-1 turns ratio on the primary to secondary, and we'll talk more about that later. I know that's a little more of a turns ratio than we typically apply for an End-Fed Halfwave, but that helps with the tuning, so we'll get there. Just bear with me. Turn number 4. Try not to kink the wire here. Turn number 5. 6. 7. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 28. 29. 30. So I'm going to do some more here just for good measure. It's always easier to remove turns than it is to add them. Thirty-one. 32. 33. 36. 34. 35. And last one. We'll stop at 36. If that's not enough, well then, something may not be right. Alright. Let's do a little twist. On this stub that's going to go to the center. Just to make that a little easier to work with. I think that'll do. Cool. Alright, let's get that BNC connector ready. So we're going to do a little bit of modification on our BNC connector here again, just like we did last time on that 9-to-1. So what I want to do is round off this 90-degree edge right here on the top, and I also want to get rid of this little lip right here. That lip that you can maybe see. Yeah, there we go. It's going to be in my way. That's where the surface mount capacitor is going to go, between the ground and that center conductor inside. Let's do a little grinding here. That looks pretty good. Use my cutters here to deburr slightly. I think we're all set. You can see that nice 90-degree edge is gone, and so is that right in there. So now I've got a nice smooth transition from the center conductor out to the ground here. Let's fire up the soldering iron. So I got the thin tip on here, but I'm going to swap that out for the fatter one, because I need to get a lot of heat onto the part in order to solder that ground. So we can go with the fatter tip. It's going to make our life a little easier. Fire it up. Alright, we are up to temperature. A little sip here. Let's get started. Alright, I got my fancy BNC connector holder here to keep me steady while I get this soldered on. I'm going to make a nice solder pad here on the ground. That's kind of my first goal. There we go. to do. I'm going to swap out the solder tip. So I swapped out my solder tip for a much smaller one here. I'm going to tin that center conductor. And get it tinned all the way down into the hole there. There we go. So next up, we got to get one of these tiny little surface mount capacitors soldered onto this thing. Tweezers are a huge help for this because these are not very big. Some of the other options, for example the 1 kilovolt rated ones, are a bit larger, but you can just see how ridiculously small this thing is. Let's get it into position, get a little solder going. Clean up my solder tip. Make sure I don't short out to ground. There we go. Let's solder the ground side of that. So we're placing this capacitor in shunt across the input, basically from the center conductor to ground. Here we go. That's it. So the capacitor's installed. Doesn't look like I've got any shorts there. I think we're good. I could test that with a multimeter just to verify. So if I go from ground, the center conductor, no short. So we're good. Next step, we gotta get this guy installed. I'm gonna burn the enamel off of these stubs here. There we go. Some nice clean copper there. So I'm worried I took a little too much enamel off of that wire going to the center conductor, and I don't want it to short out, so I'm just going to put a little piece of electrical tape in here to protect it. That's all going to get hidden away on the finished product anyway. Let's go ahead and tin these wires. There we go. Let's see if we can solder this into place. It's probably one of the hardest parts of this build. Extra challenging trying to do it on camera. So that little stub needs to go into that center conductor. This little stub goes to ground. All right, got the center conductor. And I think I need to switch back to the larger solder tip. All right, I believe I've got the ground soldered as well. So this should be ready to go, with the exception that we need to fine tune this. So let's talk a little bit about why we made the transformer with a 12:1 turns ratio. What I've found in building a whole bunch of these End-Fed half-wave antennas is that some of them want a little bit more or a little bit less transformance to bring you right down to that perfect 50 ohms. The other thing I've noticed is that on the higher bands, let's say 20 meters and 15 meters, you need less transformance ratio than you need, say, on 40 or 80 meters. So if you're going to build a trapped version of this, like we're going to, you want to center that, that resonant frequency, that perfect transformance ratio in the middle of the band. So I'm going to build this antenna for 20, 30, and 40 meters. So I'm going to tune this transformer to have a perfect 1:1 50 ohm pure resistive match at 30 meters. Let's go do that. So I've got kind of an interesting strategy for this. I hook the partially built matching unit up on my antenna analyzer. Just temporarily hook it up to some wire. And I've got that attached to a spool that can feed out wire as I walk backwards. And I kind of just keep walking back until I get that resonance in the right spot. And I'm looking for the 30-meter band to be right about at the 30-meter band. You can still see I've got 1.62 to 1 SWR, 1.64 or so at the low point there. So let's take a look at what our resistance is here. So our resistance here is 30 ohms. That means we've got too much of a transformance ratio here. So we need to remove some of these secondary winding turns. Let's go ahead and do that and retest. All right, so I removed a few turns. And we're doing pretty good here. We're down to a 1.13 to 1. So my wire's a little long. Let's see what our resistance here is at resonance. Right about there. So we're still at 44 ohms. So still just a little too much transformance even with that 10 to 1 turns ratio. So let's pull, let's say 1, maybe 2 more turns off of there. Let's go with 2. So there's 1 removed and 2. So now we're at a 3 to 28 turns ratio here. Let's hook this back up and give it a try. All right, I've got my wire reattached. Oh yeah, we're looking good there now. So we're still just a little long on the wire. We're at 1.02, 1.03 to 1, basically 1 to 1. You can see that nice 51 ohm match right there. Almost perfect. I don't think we're gonna get much better than this, so let's go ahead and finish this puppy off. So if you guys are wondering how I did that last part where I was tuning the antenna, I use a spool of super cheap wire. This stuff is like $8 on Amazon for 1,000 feet. It's solid conductor, 30 gauge. I think it's copper wire, nickel plated, with just a real thin sheath on it. Not much to it on the jacket there, but it works fine for experimenting and testing and things like that. So I take this, I set this spool up either on a pole with a piece of cord through it to hold it like that and hang, and as I pull away from it, it unspools, unfurls more wire, and I just walk backwards and pull wire out until there's about a half wavelength, and I keep testing with the antenna analyzer. I can tell when it hits, when that dip in the resonance hits the right point, the band I want to test the antenna on, and I just stop there. The wire that's wound around the spool at the end really doesn't impact the antenna much at all, so it's kind of a fun little tip that can help you out with your antenna testing and design. And also, even if you just want to make an antenna, say an End-Fed Halfwave, and make marks on the wire, and only unfurl it until it's at the 20 meter or 30 meter or 40 meter point, and just leave the rest wound up on an antenna line winder. Works great. So we're going to take an actual piece of decent quality antenna wire here to finish this off. I'm going to take about 4 inches of this Poly Stealth. This is a 26 gauge nylon jacketed copper clad steel wire. Fantastic portable antenna wire. Stuff is what I use to make probably most of my portable antennas. Tin the tip of that. Iron's a little hot, but it'll do. And we're going to tin the tip of the wire here. We got to get this wire into place. I'm going to send it down through the top here. Well, maybe it'll be easier to come up from the bottom. Let's try this. My goal, there we go, is to get it to come out the center conductor hole there on the top. Work that wire through, and I need this end to actually go come out up here. This ends up being a fun little game of push and pull. Get it all into place. There we go. So that's pretty good. And my last step here is to solder these two pieces together. All right. Got a real small piece of heat shrink to go on here. That's going to cover up the solder joint. And these two ends need to come together. A little bit of a challenge. We'll get it. There we go. Oh, I let it go too soon. It was still hot. Let's try that again. There we go. heat shrink settled in. And snug up this wire. Gotta feed that down in there, pull this up and through. And there we have it. Need an epoxy coat and some heat shrink to hold it all in place, but that will do. That's our End-Fed Halfwave matching unit. Adding a piece of heat shrink here for some strain relief. Let's go get some epoxy. So I've got epoxy all around this now, and that'll harden up pretty good, hold everything secure and in place, keep that fragile wire from getting broken or pulled out. I've got a little bit of a bare spot right in there. Let's put some epoxy on it, but that's going to get covered up by heat shrink anyway, so I'm not worried about that. Should be pretty well set here. So let's let that epoxy cure. It's 5-minute epoxy, so it'll be just a short amount of time. Alright, got my heat shrink here. Let's get this bad boy covered up. That looks pretty good. go. Once that epoxy finishes curing, we're done. This is our End-Fed half-wave matching unit in a tiny little package right on a BNC. Next iteration of this video, we'll be adding some traps to this and making this a multi-band End-Fed half-wave. So there you have it, my friends. That's your miniature End-Fed half-wave on a BNC connector. Hope you guys enjoyed the show, and I hope you'll tune in next time when we build some traps and turn this into a multi-band antenna for the MTR-3B. Till then, I'm Adam with K6ARK Portable Radio. We'll see you soon.